Hello, grade 9 Briggs and grade 9 Bernoulli students. So, we're now through discussing on how to solve systems of linear equations by graphing, substitution method, and elimination method. So, let us now apply our knowledge in solving systems of equations by solving word problems. So, we have here a warm up. The school that Wilbur goes to is selling tickets to play. On the first day of ticket sales, the school sold 2 adult tickets and 10 child tickets for a total of $158. The school took in $133 on the second day by selling 7 adult tickets and 5 child tickets. Find the price of an adult ticket and the price of a child ticket. That's the question. What is the price of an adult ticket and what is the price of the child ticket? So let A be the price of an adult ticket and let C be the price of the child ticket. Okay, A adult, C child, right? Okay, so you can see on the first day, 2 adult tickets and 10 child tickets cost $158. So our equation 1 will be 2A plus 10C equals 158. And we have here also the school took in $133 on the second day by selling 7 adult tickets, 5 child tickets. So 7A plus 5C equals $133. So we already have here the system of linear equations. We can now solve this by substitution, elimination, or graphing. What do you prefer? Okay, we solve using this elimination method. Okay, we cannot just graph these large numbers on a Cartesian plane. So let us multiply equation 2 by negative 2 so that 5c will become negative 10, so that c will be eliminated later on. So negative 49 minus 10c equals negative 266 for equation 2. Then we can now cancel c, the variable c. 2a plus negative 14a is negative 12a equals negative 108. 158 plus negative 266 is negative 108. Divide both sides by 12. A is equal to 9. Now solving for c, substitute the value of a in equation 1. 2 times 9 plus 10c equals 158. 159 minus 8. 158 minus 18 is 140 divided by 10, 14. So the price of an adult chicken adult ticket is $9 and the price of a child ticket is $14. This is a warm-up. Another model problem. The sum of the digits of a 2-digit number is 7. When the digits are reversed, the number is increased by 27. Find the number. Okay, let T be the 10th digit, U the 1st digit or the units digit. And the sum of T and U is 7. And when we are going to reverse the digit, the number is increased by 27. So the original number is 10T plus U. Yes. We multiply 10th digit by 10 and we multiply units digit by 1. So U, 10t plus U, original number. Now if we're going to reverse, pagpalitan lang yung 10 and U. So 10U plus T is the reverse number. So when the digits are reversed, the number is increased by 27. So what will be our equation here? Ganito. So since the sum of the digits is 7, T plus U equals 7 is our equation 1. For our equation 2, if the number is reversed here, 10u plus t, the original number is increased by 27, right? 10u plus t, the reverse number is equal to the original number 10t plus u plus 27. Solving for equation 2, simplifying, 10u minus u, 9u, 10t minus t, 9t plus 27. So equation 2 is 9t minus u equals negative 27 or t minus u equals negative 3. Substitute na natin dito. We can now cancel u. Then add t and t. 2t equals 7 plus negative 3 is 4. t equals 2. Solve for u. Then yes, substitute here. Equation 1 or 2. Okay. So since t is 2, 7 minus 2 is 5. Yes, that's the value of u. T is 2, u is 5. That means the tens digit is 2, the units digit is 5. That means the 25. The number is 25. So the original number is 25. The reverse number is 52. The reverse number is 52, right? So you can see 2 plus 5 is 7. If we reverse this, 52. And 25 plus 27 is 52. Okay, diba? Tama. Another model problem, the sum of the digits of a two-digit number is 7. When the digits are reversed, the numbers increase by 27. Find the number. Yan. So, okay, meron, di ba na-solve na natin to? Solve na natin yan. The answer is 25. The original number is 25. Yun. Yun, that means, yan. Yun, sinubstitute lang natin yun. From original number, 2 times 10 plus 5 times 1, 25. 5 times 10 plus 2 times 1 is 52. Yun. Okay, another. Sum of the digits of certain two-digit number is 13. Reversing its digits increases the number by 9. Okay, this has the same solution as our problem in the previous problem, I should say. So the sum of the digits, so original number is 10t plus u. The reverse number is 10u plus t. T 10th digit, u 1st digit, and the sum of the digits is 13. So 10t plus u is 13. And then we're going to reverse the number. 10u plus t is equal to the original number 10t plus u plus 9. Okay, increases by 9. Simplifying equation 2, we have 10u minus u is 9u. 10t minus t is 9t plus 9 equals 9u. Divide all terms by 9, t plus 1 equals u, or t minus u equals negative 1. So this is equation 2. We can now cancel, or yes, we're gonna eliminate u. So 2t equals 12. 13 plus negative 1 is 12. Divide both sides by 2, the answer is 6. So if t is 6, what is u? Substitute na natin dito. 6 plus u equals 13. 13 minus 6, 7. Therefore, the original number is 67. As you can see, 6 plus 7 is 13. And then if we reverse this, 76, it's equal to 67 plus 9. 67 plus 9 is 67. Yes, 76. Okay. Yun. 76. So, yun yung answer niya. Alright. Next, the sum of the digits of a certain two-digit number is 11. When you reverse its digits, you decrease the number by 63. Find the number. Now, same procedure as we did in the previous problem. Original number 10t plus u. Reverse number 10u plus t. T 10th digit, u 1st digit. So for our equation 1, since the sum of the digits is 11, t plus u is 11. And then second equation, 10u plus t. The reverse number is equal to the original number minus 63. Decrease kasi. So ito na yung solution. So for the reverse number is equal to original minus 63. 10u minus u, 9u. 10t minus t, 9t minus 63. Divide all terms by 9. U equals t minus 7. Then we use substitution method here. Okay, substitute u by t minus 7. 2t minus 7 equals 11. 2t equals 18. Therefore, t is 9. Then what is u? Yun. Dito substitute natin. 9 minus 7, 2. So therefore, the original number is 92. The reverse number is 29. Tama. You're going to reverse the original number. 92 is 29. Yes, it's equal to 29 is actually 92 minus 63, right? So 10th digit is 9, units digit is 2. Now let us try to solve another problem that involves speed of the boat in still water. So a boat traveled 60 miles downstream and back. The trip downstream took 3 hours. The trip back or the trip upstream took 30 hours. Kasi mas mahirap pag upstream, no? Downstream, mas madali. 3 hours. What is the speed of the boat in still water? What is the speed of the current? Okay, let's recall the formula for the distance is rate times time. Speed of the boat times time is equal to the distance. Okay, D equals RT. So it says here, boat traveled 60 miles downstream took 3 hours. Okay, 60 miles equals 3R. That means R is 20 miles per hour. For that's the rate of the boat downstream. For upstream, D equals RT, 60 equals 30R. Divide both sides by 32 equals R. And the speed of the boat upstream is 2 miles per hour. Nako, mas mahirap kasi. Bilis siya downstream pero upstream mabagal. So the question is, so our equation here is for equation 1, velocity plus current equals 20. Kasi downstream tayo. Tapos pag upstream, velocity minus current equals 2. Right? Ito yung downstream plus. Yung upstream minus. Speed of the boat yung V, speed of the current yung C naman. Right? So we can now solve this by elimination method. Okay, we can now cancel C variable. 2B equals 22, divide both sides by 2, V equals 11. Solving for C, 20 minus 11 is 9. So the speed of the speed of the boat is 11 miles per hour, while the speed of the current is 9 miles per hour. Yan, tindihan. Ganun lang pag-solve yan ng mga motion problems in the water. Another example related to, same problem as in previous. A boat traveled 352 miles downstream and back. The trip downstream took 11 hours. And the trip back took 22 hours. Find the speed of the boat in still water. So downstream, distance equals rate times time. 352 equals 11 hour. So sa downstream, 11 hours siya. 352 divided by 11, 32 miles per hour. That is rate in the downstream. What is rate upstream? 352 equals 22 hour. Yan, upstream, the trip back. So 352 divided by 22, 16 miles per hour. Now find the speed of the boat in still water. So yan, yun, nasolve na. So V is the speed of the boat in still water and C is the speed of the current. So pag downstream, we have here B plus C equals 32. Pag upstream, B minus C equals 16. Then cancel C, 2B equals 48 divided by 2, 24. So the speed of the boat in still water is 24 miles per hour, while the speed of the current is 8 miles per hour. Okay, we have here another. The sum of the digits of a certain 2-digit is number 16. When you reverse its digit, you decrease the number by 18. Okay, it's the same problem as our problem in number 1 and 2. 10's digit for T, U, 1's digit. Original number 10T plus U, reverse number 10U plus T. So for our equation 1, the sum of the two digits is 16. So T plus U is 16. And then when the reverse number 10U plus T is equal to the original number minus 18, decrease by 18, sabi. So let us solve for T in terms of U in equation 1, 16 minus U. Here let's first simplify. 10T minus T is 9T. Minus 18, 10U minus U is 9U. Divide all terms by 9 para maging T minus 2 equals U. Then since T equals 16 minus U, let us now substitute this value to this equation. 16 minus U minus 2 equals U. So that negative 2, U plus U is 2U. 16 minus 2 is 14. Divide both sides by 2, 7. U is 7. What is T? 16 minus 7 is 9. Therefore, the units digit is 7, the tens digit is 9, and the original number is 97. Okay? And if you reverse this, it becomes 79. And 97 minus 18 is 79. So for your homework, answer linear systems application number 1 and number 2. Yeah, I think it's just the same as upstream and downstream problem. So you can relate these two problems with those problems back in our examples. So that ends. You can screenshot on this part, answer this with solution. Okay, goodbye. Thank you very much.